This hour, NASA is revealing its new supersonic jet that flies without producing loud sonic booms.
After 6 intense years of pioneering development, NASA and Lockheed Martin have finally revealed their groundbreaking quiet supersonic aircraft, the X-59 QueSST. What state-of-the-art technology does it bring to the table? More importantly, why will it strike fear into the hearts of Russia and China? Let's find out in this episode. Before we dive into the answers, we first need to know, what is this aircraft and how was it created? NASA and Lockheed Martin's unveiling of the X-59 marks a major step forward in addressing the long-standing challenges of supersonic flight. Designed under NASA's Quiet Supersonic Technology, or QueSST, program, the X-59 is a groundbreaking aircraft built to solve one of supersonic travel's most persistent problems, the disruptive sonic boom. This boom occurs when an aircraft traveling faster than the speed of sound generates shock waves that merge and reach the ground as a loud and sudden explosive noise, which has historically been the Achilles heel of supersonic travel. For decades, this phenomenon has limited supersonic flights to over-ocean routes, far from densely populated areas, making it impractical for widespread commercial use. For example, the Concorde, an iconic supersonic passenger jet, achieved speeds over Mach 2, but was severely limited by its noise output. Its powerful engines and delta wing design produced intense shock waves, causing booming sounds that reached the ground with considerable force. People living below flight paths described the noise as explosive, with reports of broken windows and structural vibrations. Public backlash led to the U.S. Congress banning civilian supersonic flights over land in 1971, a move followed globally by 1973, confining Concorde's operations to oceanic routes. However, in 2016, NASA set the stage for a groundbreaking project by inviting Lockheed Martin and other aerospace companies to propose designs for a test aircraft. The goal was ambitious: to prove that supersonic flight over land could be as safe and quiet as subsonic airliners. The target noise level was set at 75 decibels, a measure of perceived sound, which is about as loud as a dishwasher running for less than a second. For context, the Concorde's sonic boom was 105 decibels, comparable to the roar of a chainsaw. Fast forward to 2018, NASA awarded Lockheed Martin a $247.5 million contract to build this revolutionary low-boom aircraft. Officially named the X-59 in June 20th, 18 under the QueSST program, the project faced significant challenges. By November 20th, 18, Lockheed Martin had begun machining the first parts of the X-59 in Palmdale, California, and by May 20th, 19, major structural components were assembled. The X-59 made its first public appearance in August 20th, 23, though it was still awaiting its final red, white, and blue livery. The official debut came on January 12th when NASA and Lockheed Martin proudly presented the X-59 quiet supersonic aircraft. NASA Deputy Administrator Pam Melroy highlighted the achievement, stating, "This is a major accomplishment made possible only through the hard work and ingenuity from NASA and the entire X-59 team. In just a few short years, we've gone from an ambitious concept to reality." The aircraft is powered by a single General Electric F414 GE100 engine, located near the tail, which produces an impressive 22,000-pound force of thrust. This engine is known for its reliability and power, commonly used in military aircraft like the FA-18EF Super Hornet. The X-59 has a maximum takeoff weight of just over 16 tons. It features a single-seat cockpit derived from the Northrop T-38 Talon, providing a streamlined and efficient design. The landing gear is adapted from the F-16 Fighting Falcon, ensuring robust and reliable ground operations. In terms of performance, this aircraft is built for balanced speed and efficiency. It can reach a maximum speed of 990 miles per hour, which is approximately 1.5 times the speed of sound. Its cruising speed is slightly lower at 940 miles per hour, or Mach 1.2, optimized for sustained supersonic flight. The aircraft operates at a high altitude of 55,000 feet, allowing it to conduct tests in a controlled environment. Now, while the X-59 isn't designed to match the blistering speeds of an ideal supersonic airliner, about 2 or 3 times the speed of sound, its true purpose lies elsewhere. What really captures people's interest is, will it be able to remove the deadliest issue of supersonic travel? When a plane cruising below the speed of sound waves ripple out evenly in all directions, but once the plane breaks the sound barrier, it outruns its own sound, causing the waves to bunch up into a powerful shock wave. This results in a loud sonic boom, which continues as long as the plane flies faster than sound, affecting everyone within a cone-shaped zone below its path. The X-59's design cleverly ensures that shockwaves don't merge into a single powerful blast. Instead, its uniquely shaped surfaces scatter the waves, spreading them out and reducing their impact. One of its most striking characteristics is its elongated and slender nose, which accounts for over a third of the aircraft's total length. This aerodynamic design plays a critical role in minimizing drag and facilitating smoother airflow over the aircraft's surface. The long nose helps to prevent the formation of shock waves, which are responsible for creating the disruptive sonic booms associated with traditional supersonic aircraft. By extending the nose, the X-59 can direct shock waves more efficiently, dispersing them in a way that reduces their intensity as they travel toward the ground. In addition to its distinctive nose, the X-59 incorporates twin canards located just ahead of the main wings. These smaller, forward-situated wings enhance the aircraft's stability and control during flight, particularly at supersonic speeds. The canards work in tandem with the main wings to optimize lift and maneuverability while contributing to the overall aerodynamic efficiency of the aircraft. Their design also aids in directing airflow around the fuselage, further minimizing the potential for shockwave convergence, which is essential in mitigating the noise generated during supersonic flight. Another critical aspect of the X-59's design is its top-mounted engine intake, which strategically positions the engine above the fuselage rather than beneath it. This configuration is vital for noise reduction because it helps to deflect the sound produced by the engine away from the ground, thereby decreasing the impact of the sonic thump on the populated areas below. The smooth fuselage of the X-59 is devoid of protruding elements, which allows for uninterrupted airflow and minimizes disturbances that could amplify noise levels. Additionally, the cockpit features an enhanced vision system that replaces traditional forward visibility for the pilot. This system utilizes a forward-mounted 4K camera and multispectral imaging technology, providing a comprehensive view of the environment ahead, including runway and obstacle detection during landing. This innovative design not only enhances safety and operational capabilities, but also reflects the advanced engineering efforts that have gone into developing the X-59 as a pioneer in quiet supersonic travel. In January 20th, 2024, the X-59 was officially unveiled, marking a major milestone in the project, with its first test flight planned for later in the year. While primarily focused on civilian applications, the X-59's low-boom supersonic technology will propel the U.S. to the forefront of military aircraft development, and it will send shockwaves through Russia and China. Why? Because this is a breakthrough in reducing the noise signature of high-speed aircraft. Supersonic flight typically produces a loud sonic boom, which can alert enemies to a jet's presence in contested airspace. The X-59's low boom technology, however, effectively masks this sound, allowing aircraft to fly at supersonic speeds without announcing their approach. If adapted for military purposes, this capability would give the U.S. an edge in stealth operations, as future American aircraft might enter hostile airspace undetected. This advancement could also influence the future design of fighter jets, as the technology behind the X-59's low boom capabilities can translate into enhanced efficiency and aerodynamics. The unique shaping of the X-59, including its elongated nose and smooth fuselage, is engineered to control shockwave formation, resulting in a quieter flight. Should this technology be applied to military jets, these aerodynamic principles could improve fuel efficiency, speed, and stability. Russia and China may see this as an advantage they will need to counter or match to ensure their fighter jets can compete with potentially quieter, more efficient American aircraft. The development of low-boom technology could further intensify the global race for advanced supersonic and hypersonic capabilities, as NASA's public demonstrations of the X-59 will likely push Russia and China to enhance their own programs. With the U.S. exploring more viable supersonic travel options, Russia and China may feel compelled to accelerate their research into both low-boom supersonic jets and hypersonic technologies. Hypersonic aircraft, which prioritize speed and maneuverability, already represent a significant area of focus, but the added dimension of sonic boom reduction might drive these nations to consider quieter designs in their hypersonic and supersonic fleets. Lastly, NASA's progress in low boom technology could eventually lead to changes in international airspace regulations, potentially lifting bans on supersonic flight over land. If these bans are relaxed, Russia and China might feel the need to follow suit with their own low-boom military technology to maintain parity. Regulatory shifts could prompt these countries to conduct tests on similar technologies, integrating low-boom principles into military jets and potentially reshaping the dynamics of airspace use. As the X-59 opens new possibilities in aviation, Russia and China will likely be keeping a close watch to avoid any strategic disadvantage.